Good afternoon, everybody. Welcome to class this afternoon. As we get started today, I just want to give you a brief thank you, whether you're watching this with me live or whether you'll be watching this later on. You know, even though you're probably like, "Oh, Mr. Ramsey, you said I was going to be, so responsible for the material, so why are you thanking me for watching?" But I appreciate your watching. I hope you're getting something valuable out of this. I hope you find that it's worth your time. That it's more than just something that you have to do to get some information, because we don't I like to kind of go over some stuff, and I think it's more beneficial than just you sitting there reading stuff sometimes, just because I think it helps get things out there better and helps you to hopefully wrap your head around it a little bit better. So I really appreciate that you're taking the time to watch this, whether now or later. But today we're talking about functions, and it's here where things really start to ramp up. In the past couple of modules where we've been getting started, we've had a little bit of this and that about just some basic things. Like in the first module, I just wanted to try to get you into doing a little bit of code and just getting started with stuff. And now I'm trying to take you to the next step, get you a little bit further. And we're actually going to start to do some real code in these. Before we've just kind of done some variables and some operators and some this and that, tiny things. But with what we're going to be doing today, with moving into functions, it's going to start to look more like code that you've seen elsewhere. Look more like the movie code that you might have seen. So let's get to talking about functions today. So I think the first thing that we need to do when we're talking about functions is just kind of define the term. What is a function? So when we think about functions in programming, and in different programming languages, we call these things different things. Like if you go on to take Java or something like that, we'll call them methods in Java. In JavaScript and in Python, we call them functions. And so a function essentially is just a named sequence of statements that perform some useful operation. So we have just a series of statements that do a thing. Right? So up until now, we've just kind of been writing our statements, and we've just kind of been putting them in a script. But now we're going to start to take the things that do similar things and group them together in a function. Now, functions may or may not take something that we call arguments. And we can think of an argument as kind of like a variable. But it's a variable that is only for that function. When we define the function, we will add, in between the set of parentheses, we'd add a variable name. And then we can use that variable name inside of our function. And then when we call that function, we call it with some kind of data in between the parentheses that will take the place of that argument name in the function when it's executed. So what arguments allow us to do is they allow us to take data and transfer them between different functions, or transfer them from just standard code into a function. And so I think that'll become a lot more clear to you when we get to our demonstration and we actually start doing something like that. But I think a bigger question than what is a function is why do we use functions? So I've got a big slide with a lot of words on that. So essentially what we're doing when we're utilizing functions is we're taking our program and we're dividing it up into several parts. Why are we going to just take our time and do this extra stuff where we're going through the trouble of dividing our program into functions? And we have several reasons why we do that. One is that creating a new function gives you an opportunity to name a group of statements. So, it's kind of one of the things that we were talking about last week in regard to variables. When we make a variable name, we give it a descriptive name That way we know later on what that variable is for. So it's a similar type of thing here when we're creating our functions. When we create our functions, we're going to give our function a descriptive name. And the code that we put inside of that function is going to be code that's all related to this one specific thing. So that way, when you go back to that function later, you know that, oh, this is the part of my code that does this. This is the part of my code that takes an input from a user. This is a part of the code that does this calculation. This is the part of the code that does this or that. You know immediately. And so you also know that if something goes wrong with a certain calculation, or if something goes wrong with the input, then the code where something went wrong is isolated to that particular function where, you've given it a name. Functions can also make a program smaller by eliminating repetitive code. So whereas, you might in a function write a ton of lines of code, 6, 8, 10, 12, 100, however many. And if you want to execute that code multiple times when we're writing a function, with the way that we've been doing things up to now, well, you'd have to copy that code and put it in again and then go back through and change anything that you need to change. But with a function, all we would do is we would just call that function again, which is a single line of code. So we can take a whole bunch of lines of code, truncate them down to a function call, and so then if we have to use something multiple times, we can just use it multiple times as a function instead of having to copy all of the lines of code that we've used previously. And debugging is a big thing. One of the things we'll talk about kind of as we just progress through doing things is this idea that we call intermittent testing. So if I've taken my long program and I've broken it down into parts via functions, what I can do is that at each point in my program, I can test my function just to see if it's going to work. And so if I can go through and I can test my function and I can see that my function works, well, then I know that that function's good. So if I'm having problems later on down the line, I don't have to go through the entirety of my code to find the little place that's wrong. I can skip the things that I've previously tested that I know are good and go to the newer areas that I think might be a problem. So that's another thing that functions allow us to do, and we'll do that when we kind of get to our demonstration today. And the final thing here, and it's a big one, is that when we have a well-designed function, we have a nice chunk of code that we've isolated, we can use it in many programs. So we're not just delineated to just using it in one program. One of the functions that I'll show you when we get to our demonstration portion today is my user input function. And every program I write with an input, I like to use this particular user input function, because it can work in anything, and it can work multiple times in anything. And if I wanted to, I could put it in its own sort of library file, like when we were looking at the math library, or we will be looking at the math library. That was a little trick that I gave you guys for last week. I could put it in its own sort of library file or its own sort of module file and import that same file into a bunch of my different programs, so I don't have to keep doing it over and over and over again. Or I could just go back and copy and paste it into whatever program I'm working on, so I don't have to come up with something new every single time. And when I craft it in such a way where it's not specific to this program, where it is a well-crafted function, I could just paste it in there, and then you don't have to worry about it. So when we create new functions, what we do is we define a function. It's a definition. We call this a function definition. And so the name of a new function and the sequence of statements that follows, that execute when the function happens, is called the function definition. And we have an example here of our function definition. And we have several things to note just in this very simple function definition. So we can just take some time and we can just kind of go through this. The first thing we have is just this keyword def. Keyword def. DEF. We use this to start every one of our functions. Def, short for definition or define, is going to define our function. So that's how we remember that we use def to start our function. Now, once we have this def in here, then we can put the name of our function. And so in this instance, we have a hello world function. And so we can name this just like a variable, right? And we follow the same rules that we were following that we talked about last time for naming our variables. You know, can't start it with a number, no special characters except for underscore, PEP 8 rules, all lowercase letters, separate words with an underscore. The only thing that's different here between our function and a variable is this set of parentheses that we have here. And so we have this set of parentheses here, and we utilize this set of parentheses for every function that we write. And sometimes that'll be empty. We just leave it empty like we see it here. And sometimes we'll put something in there. And this is where our argument goes. So when we want to have that special variable that's just for this particular function, this is where we would put the name of that variable. And that lets our interpreter know that when this function is called, it should be looking for some data inside of the parentheses in that function call that it'll pass through as the argument. Now we have a colon at the end of this line here. Colon's important. Because really what we're looking at here, and especially in Python, whenever we have a statement with the colon at the end of it, what that means is that everything that follows that statement belongs to that statement. Now in Python we do something a little bit special with things that belong to a statement. So everything that belongs to this hello world function, we indent. So everything that belongs to this function is going to be indented in underneath this function. And that's how we let our interpreter know. We have this colon here. That lets it know to expect some lines coming that belong to this function. And then everything that belongs to this function, we're going to indent it in underneath the function. And when we're ready to start a new function, or when we're ready to start a new section of code, well, we just unindent to let it know that we're starting something new. And that's unique to Python. If you've ever coded in any other programming languages, you'll know that tabs and spaces and all that kind of stuff, they are more for just code readability, making your code look nice than anything else. Like if you're working in JavaScript or you're working in Java, indents don't matter at all, but you put them in there to make your code look nice and look readable. In Python, they're critical. However, it also gets you into good practice of writing code with indents so that if you go into another programming language, you're already kind of used to doing it. So in the languages where it's not important, you'll still do it because of where Python, it is important. But essentially what we see there is just like, oh, we have our starting line, this definition line, or when we get to conditionals or loops, we have a similar sort of statement. And then everything that belongs to that is going to be indented in. And then when we're ready to start a new section, we just back out our indent and start coding that way. And if we wanted to start a new function, we'd have our starting line, and then every line underneath it that belonged to that line would be indented. So you'd see kind of a little structure like that. And we'll do that when we get to our demonstration portion today. That is absolutely critical, absolutely important in Python. Now, one of the great things is that since we're using an IDE, when you tab, it'll tab to the right spot for you. And oftentimes when you end a line with a colon, like we see here, and hit enter, the IDE is going to know, okay, they put in a colon. That means they're ready to start some kind of statements that belong to this previous statement. So I'm going to know to already indent. And really, technically, another good thing about the indents is that they put the indent in the right place for us, because a Python indent isn't exactly a regular indent. It used to be a whole lot more complicated back before we saw this proliferation of IDEs that we could use quickly and easily, because the Python indent is actually 4 spaces. But if we're using an IDE, if we're using one of these integrated development environments like REPL or like idle, it knows that already. So it already has 4 spaces mapped to the indent. So it's smart for you. It's going to help you out. It's going to be friendly, which is pretty great. But just remember that this formatting is incredibly important when we're approaching issues in Python. If you don't get the formatting right, your program won't be correct because it won't work. Here's a little bit more about Python formatting. It's basically what we just talked about, but I want to throw this up on the screen just in case you want to take notes here. Essentially, we call that line where we name our function, that defining line, we call that the head of our function. And everything that belongs to that function is called the body of our function. So we take and we indent the body of that function to show that it belongs to that particular function. By convention, the indentation is always 4 spaces, but since we have an IDE, it's going to know tab for us. And this is the same kind of structure that we use also with conditionals, with loops, with other data structures. So if we learn it now, we can kind of apply it to the other things that we'll be doing in the near future. Now, it can be a little difficult to keep straight, right? Trying to think of, where everything should go. That's one of the toughest parts of it. But if we're mindful of it and we are putting our effort into it, it's not a big deal at all. So once you have a function, one of the next things that you have to do is call it. Now, let's look at a function in action, okay? Let's just kind of skip around and do that just a little bit. So let me pull up my REPL window here. Boom. And we'll go full screen. So I'll start a new Python REPL. We'll just let it be the default name. And I'm going to go ahead and put in my shebang. Remember, we put in the shebang. That was module 1. You guys, that should be old hat to you all by now. So that is #bang /usr/bin/env Python 3. Now let's write that little hello world script that we had written previously. And we'll do it in a couple different ways. So when we're writing our function, we're going to start out by defining our function, def, and we'll just write that same function that we had previously, hello world, and our colon at the end. Now, one of the things that you'll read about in the module is something that I believe the module calls fruitful functions and fruitless functions. You'll also hear them termed as void functions and value functions in other programming languages. And that is just kind of based on how we get out of our function. So if we're writing a function and we end it with a print statement, where everything that this function is doing is contained within that function, and that is a void function or a fruitless function. If we end it with a return statement, to where we're returning data back out of this function that can be used in other functions or in other parts of that program, that's what we call a fruitful function or a value function. And so let's do an example of both of those now to kind of get started. So we're going to work with this hello world function. The one that we saw in our on our slide was a void function, a fruitless function. Because inside of here, we just ended it with print hello world. And so everything that this function is doing is contained within this function. So when I call this function, it's going to print hello world. Now, if I wanted to do a fruitful function or a value function, I would use a return statement. So def will call this value underscore world, include our parentheses. And what we're going to do here is we're going to return hello world. And we see the real difference in these when we do the function call, right? And that's something that's important to remember. Like if I try to run this code right now, nothing happens. Because when you have a function, that's basically some quiet code. It's some code that's kind of in the background. The function doesn't run until I make what we call a function call. Because remember, one of the things that we said we could do with our function is call it multiple times so we don't have to write this code over and over and over again. So using the function call gives us the ability to reference the code and actually cause the code to run. So I'm going to write a function call for both of these. And when we call our function, we just use the name of our function to call it. So you would just use the name, including the parentheses. So we will call hello world with our parentheses. And we will call value world with our parentheses. And when our interpreter is going through our code and it sees these function calls, it's already read these functions and it knows about them, right? So that's one of the important things to remember, is that you want to kind of put your functions at the top and your function calls at the bottom. And we'll actually talk about something in Module 4 that's going to help us do that a little bit. So let's talk about what's going to happen when we do this. Right, so our interpreter is going through, it's going to get to those function calls. It's going to say, oh, I already know that because I already read that earlier. So I'm going to go back to that and I'm going to run it. And so what's going to happen here is it's going to go back to this print hello world. And it's going to go back to that hello world function, and it's going to execute the code that's inside of that hello world function, which based on what we've indented here is this print hello world. And so it's going to print out hello world to the console. But then we have our value world function, part of our value function here. And it's returning hello world. Now when we return a value, we're returning it back out of the function so that we can use it in other parts of our program. So this is not a print statement. So our first one will work. Our second one will need a modification. So if we run these, we get hello world, and then we get nothing else. Now this function is working. It's doing what it's supposed to do. It's returning that data back out of the function that we can use in other parts of our code. But the issue is that we're not really using it. It's just returning that data and then not using it. So if we wrap this inside of a print statement, like that, now we're using the returned value that came out of that hello world function, or that value world function rather. So if I run this, we get hello world and hello world sans exclamation point, which is what we returned out of our value world function. So now we have a third type of basic function to write, and that's one that includes an argument. And so I'll write this as a void function, but we'll have an argument in here. So I'm going to create another function here. We're going to call it def to define argue world. Just make up a random name. Then we're going to put our parentheses. But this time, instead of leaving these parentheses empty, I'm going to put a variable name in here. Something like MSG for message. And I'm going to put a colon after that. And now I can type print MSG. And so this is what gets us into the real power of some of our functions. Right? Because what we have here is we have three functions. Two of these functions are really only going to be working in a specific program because they have a static string that we've put in as the print value or as the return value. But if we want to be able to put different strings in here and have them printed out, we can pass them through as an argument. And so we do that by just putting the string that we want to print inside of our parentheses when we call it. So we'll call argue underscore world, and our IDE is telling us it's expecting an argument. Right? It's expecting that MSG. And so we can type in something like, how are you? Right, so what's going to happen here is when our interpreter is reading through this, it's going to say, okay, I know this hello world function, so I'm going to run it. I know this value world function. I'm going to run it. I'm going to take the value back out of it and print it. And I know this argue world function, and it has an argument. So what I'm going to do is I'm going to take this text here, and I'm going to pass it through into this argument. And so now whenever you see that variable name inside of that function, it's going to be whatever text you passed through. And so we can run that. Hello world, how are you? And we can call these functions as many times as we want. Argue world, and put a different argument in there. And it's going to, each time it runs that function, it's going to take whatever value that you put in the argument and pass it through. I am fine. So we get hello world, how are you? I am fine. So that's a big thing about creating our functions here. And anything that we would do in any of our other scripts, we can do inside of a function. So what I think I want to do here, and we'll go back and we'll kind of revisit our slides here in just a few minutes, but I want to create a program that's going to be relatively simple, but that's going to help us explain functions in a little bit of a better way. So if you're following along with this, you might want to create a new REPL just so you can have all of your successful REPLs saved. But I'm just going to take it, I'm just going to delete this. So we'll give you one last shot to pause the video, get that code copied in if you're following along. Now, here's what we're going to do in this little program. It's going to be a really simple little program. We're going to model it after kind of a hello world program. But what we're going to do is we're going to take an input from our user. We're going to ask them what their name is. And then we're going to take that value and we're going to pass it along to another function that's going to say hello to them using their name. And so one of the things that I said I'd do is I said I would go through and I would look at the input function here, because the input function is a predefined function within Python. So that's why we kind of wait till our function module to talk about it. And I like to take my input function and I like to put it inside of another function so it's more useful in different programs. I can kind of modularize it and don't have to type, different things over and over and over again for different inputs. So I'm going to create a function called get input. So that's def get underscore input. And we're going to put an argument in here of message. Slap a colon on that. When we're asking our user for input, we want to ask them for the type of data that we're getting. So what I like to do is I like to take my input call, put it into another function so that we can kind of simplify it even more than it already is. So I'm just going to take a random variable here. We can just, because this one's not really going to have much of a name, we can call it x. And we can set x equal to input. And then in between our parentheses here, we put the message that we want it to give our user. Now I'm going to pass the message through as an argument. Like I could very well just put in a string here, like enter your name. But that takes and that makes it more static. And we don't want that. So I'm going to let us define that message at startup or at call. So I'm just going to put our message argument here. And then what we'll do is we'll use this as a value function, and we'll just return the value of x. Just like that. So this is a pretty simple function. And so one of the things that we can do here is we can do that whole thing that we were talking about earlier with intermittent testing. So I can write myself a print statement, message, or I can write myself a print statement, and inside of that print statement, I can call my get input function, and I can put the message that I want to send my user to let them know what information they're trying to send me. Enter your name. And remember that when we use a string like this, all of the characters that we put inside of our string is what gets displayed. So if we want a space between our message that we're giving our user and what they're going to type in, we need to put it in our string. So I can just use this to test. So it tells me to enter my name, and I can just enter in my name. And what should happen here is it should echo it back to us when we hit enter here. So I put in Mr. Ramsey, and it should echo back to me because we're printing the value that's returned, right? It's running get input with enter your name. Let's walk through it real quick. It's running get input with enter your name. We're taking enter your name, and that's the argument, so we're putting that in here. So this would be the same as writing input and then in parentheses, enter your name. And that's the result of that is what you get back from the input statement. And that's what we put in our variable x. And then we're returning x. And then we're printing the what gets returned. So when we hit enter here, it should just echo the name back to me because that's what I wrote in there. And that's exactly what it does. So now we know that that section works. And that's one of the powers of our functions. I know that that section works, so I can write as many other functions as I want. And if something breaks, I know I don't have to blame that one for something breaking, because I know that that one works. So now we'll write another function, and we'll write a function def say underscore hello, and we'll accept an argument of name. Because we're going to do something a little bit fancy where we call a function as an argument of another function. And so all we're going to do here is we're going to run a little print out. Print. We'll concatenate it. Hello, comma space, concatenated with name, concatenated with period space, how are you? So we've got this value function here, or this fruitful function, because it's taking a piece of data and bringing it back out. We got this void function here, or fruitless function, because everything that it's doing inside of the function. It's not passing anything back out to us. So now in order for this to be successful, we'll call a function inside of our function call as an argument. So we'll use say hello, and inside of there we'll use get underscore input, enter your name. So we have our get input function called as the argument of our say hello function, because it's returning that data back out. If our get input function was a print function, it wouldn't work here. This only works because it's a value function that we're taking data and returning it back out of. So essentially what's going to happen here is our interpreter is going to start reading this. It's going to say, okay, I've got these functions. I've put them in my memory bank. I understand them. I know there's a get input function. It has an argument. And I know there's a say hello function, and it has an argument. Now let's see what they're going to do with them. Okay, they're calling the say hello function. That looks pretty good. That has an argument with it. So let me see what that argument is. Okay, their argument here is the get input function. So let me run that get input function first. So I'll run get input. I'll take enter your name and pass it through as message. So our user gets the input message of enter your name. Whatever value they input, I'll pass it back to X. I'll return X. So that input value then becomes what we get back here as this argument. And so then that becomes the argument for our other function. So it'll take whatever name that they put in up here, pass that through as the argument here, and print out hello and their name, how are you? So we kind of get layers and layers deep here, and some things that are important to point out is that we have this one function that does one specific thing, and then we have this other function that does this other specific thing. And when we're writing functions, that's what we want to do. We want to craft our functions to where they all do specific things. And so we'll run this. We'll enter our name again, Mr. Ramsey. And we get, hello, Mr. Ramsey, how are you? And so we're passing our data between our different functions, and we're getting a nice output. Now, one of the reasons I like this get input function is I can use the same input function multiple times and just change the message. Right? So if I print get underscore input, what are you doing? And then maybe I do another one of these just to test this, just so you can see it. I print out maybe any questions. So I've written this one function that I can use over and over again that it's just going to, remember reassignment, right? We can reassign different values to our variable. So each time it goes through, it's going to pass through the different argument, and it's going to give me, that output. So for these other two, we're just going to echo back what I type in. So it's going to ask me to enter my name, and I'm going to put that in there, Mr. Ramsey. And remember, it's following everything and executing everything in order. So the input stops that execution and waits on me to tell it something. Hello, Mr. Ramsey. How are you? What are you doing? Oh, I'm just teaching. And it says, it echoes back that back out to me, teaching. Any questions? Not really. And it echoes that back out to me. So that shows me how we can use these functions properly. So we will revisit this in just a moment and write another little quick program. That'll kind of be an extension of what we did last time. But I want to revisit our slides for just a couple minutes here. To talk about some other stuff. For example, we looked at this. We looked at the parentheses in our function. I'll put this back up here for a minute, just so you can kind of have this down here to write. And it's about arguments. So the parentheses in our function is a declaration. The parentheses in our function declaration are for arguments. And we saw our example of that. And arguments can be kind of used as variables that are scoped for that particular function, which is something that's kind of important to remember, right? Is that when we use these arguments, they're specific for that function. If I try to reference that argument outside of that function somewhere else, not going to work. These arguments are kind of like variables that are specifically for these individual functions. So we have this example here. We just walked through an example. And we said that an empty set of parentheses means that there's no arguments. And the common terminology that we use for these functions is that we say that it takes an argument and returns a value. And so we've seen those kind of already. Let's look at this screen here, about flow of execution. So in order to ensure that a function is defined before its first use, you have to know the order in which statements are executed. And we call this function, or the flow of execution. And so with what we're doing so far, everything's what we call linear flow, or linear execution, meaning it just reads everything from top to bottom. So in order for our interpreter to know what functions are, we have to put them higher up than the call for that function. If I went back to our demo program there and I switched and put those function definitions down below our function calls, well, our interpreter is going to get to those function calls first, and it's going to say, I don't know what those are. I've never seen those before. That's an error. It's broken. So we want to try to make sure and take care that we're putting our functions in the right place so that our interpreter knows where they go. And everything that we're doing right now is linear. But as we progress in some of the near modules, we'll start looking at different structures. Things that kind of branch out into like a tree structure, things that are going through loops. And so the flow of execution kind of changes in those different instances. But right now we're not changing the flow of execution. We're still going through a linear flow of execution. We might just take a detour when we do those multiple function calls like we were looking at there. Now, another thing that it's important that we look at is our math functions. And this was something that I kind of tricked you with for Module 2. Because your Module 2 asks you to do the hypotenuse of a triangle. So one of the things that I kind of wanted you to do is be able to look for the missing pieces that you needed to try to figure that out, because I knew I was going to talk about them in Module 3. Because we didn't talk about this before today, but we are talking about it in relation to Module 3, because these are math functions. These are predefined functions that are in our Python library. We have to import our math library into our program so it knows what we're talking about. All of these functions that we're using here are already in Python. They're just not in the basic run of Python to try to keep memory usage low. If we took everything that was in the code base of Python and just included it in every file that you create, well, the code base of Python's huge, right? And that's just going to slow down your program. So we only include the things that we need when we need them. And so what we can do is we can look at this function, at this set of functions in our math library. And we can actually pull them up on the web. So if I just Google Python math module or Python math library, the very first result is going to be the documentation for the math functions. And this gets me things like math.ceiling, math.comb, math.copysign. These are predefined functions that actually do math for us. And one of the things that we have here that you would have needed is we actually have math.hypot. So we actually have a function here that does it for us. Hopefully you didn't use that one. Hopefully you used, where is it? Another thing that's available to us in here, math.square root. Returning the square root of x. Which is pretty interesting. And so let's find one of these here and just use it in an example so we can see how we would use something from here. Referencing this math function library is going to be something that's important to us. Being able to kind of Google it and get there so we can understand it is going to be good. Let's use, what would be a good one we can write a little program with? Well, we have the POW function here. That's also something that you could have used in your hypotenuse program. I tell you what, let's use this math function, or this math library, to write a program that'll give us the volume of a cylinder. So that'll kind of be our big program for today. We'll leave it, we'll do this program. We'll talk about one or two more things. And then we'll kind of move on for today. So we've got this. And we're going to get an input from our user for radius, and we're going to get our input from our user for height. We're going to use the same function for this. So we're going to keep this. We'll just delete everything else. If you're following along, you might want to create a new REPL so you can have a clean one with every success in it that you can go back and reference later. So we're going to leave this function here that we're going to use to get our inputs. We'll use this same function a couple times. And we will create a new function. We'll call it def cylinder underscore volume. And in our arguments here, we can actually include multiple arguments. You can include as many arguments as you want, separated by commas. So we'll include R for radius and H for height. And now we'll just put in our formula. So we'll create a variable called C volume, and we'll set that equal to pi, which I wonder if there's anything that can help us out with pi in our math module. Let's have a look at that. Is there anything here that can help us out with the value of pi? There is. Like, I'm telling you that because I already know that it exists. We have a math.pi constant here. So we can use that as pi in every equation where we're using pi. So in order to use our math module, since we have to import it, I have to import it at the top of my program. Import math. And now I can use it. So I can say math.pi. That'll give me the value of pi. Times. Now we have to get radius squared. I wonder how we can get radius squared. I wonder if there's anything in our math library that can help us out with radius squared. Well, we could probably use math.pow. Math.pow function with two arguments. The first one being the number and the second one being the power that we're raising it to. And maybe to make this a little bit more clean and clear, I might want to put this inside of parentheses. So I might go math.pow r, which is the argument that we're bringing in as the radius, and comma 2, because we're going to square it. And then so we take that, we multiply that by the height. We're going to bring that in as h. And so now we have this value here, and we can just print it to our console. We'll print the volume of this cylinder is C volume cubic units. So now we have this program here, or most of a program here, that's going to allow us to get the volume of a cylinder. So I can just kind of finish it up with our function calls. So we'll call our our first get input function call. We'll call that to a variable height equals get input, enter the height of the cylinder, radius equals get input, enter the radius of the cylinder, and then finally we can call our cylinder volume. with radius and height in the place of those arguments. So that would be radius and height. So now it's going to execute this function. It's going to take the data that gets returned. It's going to put it into that variable container. Then it's going to execute this function again. Take the data that's returned, put it in that variable container. Then it's going to take these variables, put them in our cylinder volume, and do the math with them. Now there's one very important thing that I've left out here, but I want to run it without doing it so we can see the error. So we're going to run this. It's going to tell me to enter the height of the cylinder. Maybe it's 12. It's going to tell me to enter the radius of the cylinder. Maybe it's 3. Now I'm about to get an error, so don't freak out. There's my error. Now one of the important things that we can do here is we can read this error and see where our problem is. So we have, okay, it has to do with our function call, cylinder volume, radius comma height. In cylinder volume, C volume equals math.pi, math.pow h, must be a real number and not a string. When we use our input, when we use this input function, it takes everything that our user puts in and it makes that a string when it brings it in. So, and remember that we can't do math with strings. So if we want to be able to do math with these pieces, well, we have to typecast these pieces. So instead of radius, I might say float radius. So it converts it to a floating point number. You can also do these as ints, so I can make this an int height. In this case, since we are doing the math here with math.pi, you could use these as both ints, both floats, one and the other. Either way, those are both real number typecasting. So we'll get a data value out now. However, that is going to give us another problem. It's going to give us a problem right here, because everything that we put into a concatenation string has to be a string. So we'll need to take the variable here and typecast it to a string. So now we have everything typecast the way that it should be. So now we have a functioning program that's going to get us the volume of a cylinder. So it says enter the height of the cylinder, we'll say 12. Enter the radius of the cylinder, we'll say 3. The volume of the cylinder is 339.29 cubic units. That's a successful program. We got a high level of precision there, which we probably don't need. There might be something in our math library here that would help us out with that. Hint, hint. I'll let you kind of figure that out on your own, because I think we've already done a long enough live stream. We've almost went an entire hour here. We're just like a minute shy of an entire hour. So I think that's where we'll go ahead and stop today. Let me just make sure that there's nothing else I need to cover in my slide deck, and it looks like there isn't. So let me put that program back on the screen here. So that's all that I have for you for this live stream. I'm going to put the music back on, hang out and chat for just a minute. See if anybody who's listening with me has any questions. But if you're watching this later and you have questions, feel free to email. But that's all that I have for you this time. Thank you for watching, and we'll see you next time.